Hello, what's up? My name is Anton Gorin. I'm going to present to you a really interesting and unique thing. It is a postmortem of a project named STORi that I've been working on in the past year. It is a project of generative AI. We were using Stable Diffusion and Open AI API, namely ChatGPT, in order to generate storytelling for kids. I think we came up with really interesting, innovative solutions. And even though the project was discontinued for specific reasons, I still think that we got a lot of things that we can contribute to the community. And this is a great opportunity to pass the knowledge onward. Um, I got special permission from the project leads to do this, and I'm eternally grateful for that opportunity. And this really exciting thing to do for me. So I would share my screen. Okay. So Project STORi, it was, as I mentioned, generative AI project that was about generating narratives, and specifically it was about generating stories for kids. Okay. So the STORi project was running from November 2022 until November 2023, about a year. I joined as a Stable Diffusion architect in the middle of the project, and very shortly gained more and more responsibilities. Eventually, I was managing the image generation team that was responsible for Stable Diffusion fine tuning of the models, generating illustrations for the stories, and also the narrative effort where we were doing prompt engineering to ChatGPT and thinking about how we are going to generate stories for kids, interesting, compelling, and captivating stories, engaging ones. And we've been through a lot of interesting iterations. We've been through a journey. We started from point zero where we didn't had any idea how to do this, and we slowly come to conclusions and understanding how the best approach to do this. And this presentation is about that, about the best approaches we managed to make with Stable Diffusion and ChatGPT narrative creation project. Okay, so few words about myself. I'm a generative AI expert. I'm 40 years old. I live in Israel. I dance Afro house. If you find my Instash, um, I also bake and I tell stories, a lot of stories, mainly for my kids and kids of other people in the park. I've been through a lot. I've been in data science and BI. I've been game developer for a lot of years. Then I switched to DevOps, and when Stable Diffusion came out, I switched again. And with this breadth of knowledge that I had, um, I started delving into AI. And when people from the STORi project approached me and asked me if I would be willing to join them as a Stable Diffusion architect, I was really excited because it was a convergence of all the fields that I like, because it was both infrastructure and cloud and generation, and it was AI and graphics, and it was really, really close because in games I was delving with graphics and the visuals in general. And I love storytelling and I love mythology, and I learned narrative design as a hobby and as a passion, I would say. So for me, it was an immediate sell and said, "Sure, let's do it. I'm so excited. Let's go delve into it." I've structured this presentation in Miro, so I took the working boards that we had in Miro, and I structured it as a timeline. I didn't took everything, but I took most of the interesting and stuff just in order to save some time. I cannot go over everything. but the main things are here. And I'm going to go one by one and explain what it is about, what this panel is about, what was the challenge, how we approached it, and what we did we do with it. Okay. So first, when I started, as I said, I started on March 2023. I've been presented. I've came into the project in the middle, so there was already inspiration boards. There were some initial mid-journey style concepts. The style was aimed as flat, fluffy, and child-friendly. The target audience for the project was 5 to 7 years old, and the the project by that time was already generating stories. So there was already a prompt to ChatGPT that was running and generating stories, coming back with stories. There was internal tools that were doing the ratings and a lot of cool things. What the project really did lacked is the illustration themselves. So I needed to figure out how do I do illustrations. So we have these varied, very interesting stories, and we need to figure out how do we illustrate them. We need to figure out how to automate the process that generally is done by very professional people with a lot of years in the industry. So I started out, and we already had some characters in the pipeline inside the stories themselves. What you see right now, it's already data sets from more later stages, but just to give you an idea, we had Brusek the dwarf, we had Louisa, the 9-year-old girl explorer, kind of a take on Dora, I think, but that was my impression. Neil the dragon, Luna the bat, and Moonbeam the unicorn. So these were the characters, and I thought to myself, okay, so first thing by that time, it was a year ago, March 2023. CVTI just started. It was really, really fresh out of the boxes. And Stable Diffusion 1.5 was very basic. And I said, okay, we were going to use Midjourney as a basis for fine tuning. We're going to generate datasets with Midjourney. That was clear. But what should we do first? So I did some fine tuning. And this first fine tuning, this is actually the first Louisa set. That's what we had at the beginning. I put some what you see here is Dreambooth fine-tuning parameters. So at first we used Dreambooth as a technology. We were fine-tuning the whole checkpoints, and we were fine-tuning both the image and the captions. So it was really important to use both images and captions for people who don't know what captions are. In data sets, you have images and a small text file that has tokens inside those files that encode what is inside the image. So this was our first card that we did. We used cards a lot. We used Miro a lot. Miro was really, really essential to working with the team, because the team was fully remote from every place on the globe, States, the Europe, all kind. Myself being from Israel, so we had people working remotely, and Miro was the converging point for us to communicate with each other, to pull up assets. Eventually, our team was 5, 7 people, give or take. So, and we needed this collaboration, and we used panels. So we created panels. We used this concept of panels in Miro, where we would create our own visual language in order to communicate and store data. It was super important and was really, really fun to work with. This is the first panel. This one of the first panels that we built. Here I'm trying to figure out how would we measure model. So I just did a baseline, did a quick test on a model, and said, okay, if I'm having a model, how would I measure it? So I came up with these ideas of elasticity. The elasticity first thing is how model can illustrate something it wasn't trained on, because we had a lot of stories and I need to train one model, and we had tons of stories and we need to illustrate all of those stories. So elasticity was one metric to measure how well the model can render something it wasn't trained on. Second thing I was working on is context substitution, which means that if girl just standing, I'm trying to make her wave her arms, trying to put her in other context, put the subject into other context. As you see, the model was very rigid. It was 1.5, I think. And I'm trying also to do a background substitution. So cool, we're training her on the mountains. Now let's try to put her in the beaches. And I'm figuring out, okay, how well the latent space of the stable diffusion can figure things out. And again, this is stable diffusion 1.5. It was very basic, and I said, okay, figure out we can't do anything with it. We need to prepare proper data set, that one that would really do the thing, the one that would be really versatile to handle all of possible scenarios in the stories. So I started with short recipe. So mid-journey character training set creation recipe, right? So that's my baking love showing up. So the recipe was about how are we going to create data sets. We didn't actually know how to create consistent, high quality data set with character that would be the same. So we started with the first image. We put it through Midjourney Describe and created several images. In each image, you can see we have several tokens for each image. Then we generated, then we took a very basic prompt, like picture of a 9-year-old girl, and then put each of those tokens. And this was first attempt to create sort of a library of tokens, and then we took the tokens that we thought that were close enough to the style intended, and we tried to generate pictures in various locations, doing various things, refine them, and eventually finished up with these 6. But this was only a recipe. This was only an example how we're going to do it, right? We needed to figure out, we needed to learn how to build proper data. So was an example of such learning. Second learning was about context. So how, if we already have a character, how would we develop the character further and put him in specific context? I have did specifically challenging character. I just took a character, I created a character made a boy made of nylon, which is like a puppet. We called him the Nylon Boy Experiment. And we tried to make him ride a bike. And we saw that with some iterations, image to image, specifically with Midjourney, if you take one image and put that image again into Midjourney and change the prompt, we can change the image far enough that it would get into different contexts. So the different context is the nylon boy riding a bike, but it still would be close enough to the same character. So it's not the same character, but it was close enough. That was one take. Once we figured that out, we said, okay, so we need to figure out how we're going to structure the proper board for the data set. If we're going to build data sets, how we're going to create this board. And this is where the funnel development. So we figured out that the funnel is a process where we would generate a lot of images, then we throw out the bad ones, keep the good ones, train, see what's going on, and then do the same process again. Throw the bad ones, make the good ones. So this iterative approach of always refining the data sets. That was what, in my mind, was the most important. That's why you see the funnel development. And second thing, we tried to figure out how would we create diversity. So, okay, we had this one character that looks almost the same. How we can make it coming from different things, maybe feeling different feelings. And we tried with attire, which is the clothing or what it looks like. Energies are the emotions felt by the subject or evoked in the viewer when viewing the subject. So that was what energy about. We just took a list of a lot of attributes, and from ChatGPT generated a huge list of attributes, and then picked up good ones, bad ones. This is the positive, neutral, negative energies that we picked, and we started to put those energies into the prompts. And then we also use the style. So the style, we used the same idea as here. We created this kind of library, and so we use those styles from that library and from the other. And we also checked out the format. So you can see here mixed media illustration, children's books illustration, graphic novel illustration, that all are formats. So we also checked out which format would work best. We took out different characters. These weren't our original characters from the stories. We just took different characters just to gauge the diapason of Midjourney's ability. So, what kind of character can we take? Where is the where is the where is the limit of where Midjourney starts to break? Okay, so that what the dataset funnel development was about, and that's the continuation of the same panel, and that's about action context. Once we picked up, okay, we like those characters, let's try to put them in different contexts. Try to put them in different places, doing different things. One of our first learnings that we had is that negative energies creating very interesting results. For example, you see greedy ghost is much more interesting in my opinion than cheerful ghost, but again, that's personal. Also, in anime, not human like objects, sorry, are also very hard to consistently generate, but it is possible, right? And in general, it was much easier to generate human-like figures like dwarfs or girls than cameras or even some animals. We had also a boy vampire and a dinosaur, and eventually we picked up some data set. We created a temporary data set out of that. Was also about how we're going to create the data set. It was also a really, really important point that isn't showing here on the board, but managing the data sets, pulling them down to disk, and naming them properly. That also was something that we had to learn in a proper way, in a systematic way, because I figured out that we would scale, that the project eventually would scale, and we would have a lot of data sets, we would have a lot of files, and we need to put a system in place right from the start, to put a proper system in place so that in the future we would have the infrastructure for it. So that was my kind of DevOps thinking into the stable diffusion world. We did some preliminary training. The output wasn't really good, mostly because the dataset wasn't that great, but also the base model of stable diffusion 1.5 wasn't really the greatest model. But the community started rolling out better models with time, so we would see this later on later stages. But again, we saw that we're in good direction. So the direction is right. The direction, we can create data sets, we can fine tune the model, we actually see results. And that was the most important thing. Next thing, we tried to develop more our own characters. So with the knowledge of how to create variability in characters, we said, okay, great, let's create variability for our own characters. Let's create variability for Luisa, for the dragon, for everybody. And we started creating those. One of the key learnings is that it's really, really hard to create a beautiful, appealing bed. That what you see here, it's cherry picked one of thousands, but of hundreds for sure. It was really, really challenging. We mainly ended up with kind of a cat bed hybrid. And eventually we came to our superiors and we said, you know what, we love the character very much, but it's very, very hard, and it's super hard to make him appealing and cute, and let's try something else. And we were granted that. So you can see here also Felix the Fox, one of the characters. That was the character plasticity. Here we have a styling. We tried to figure out if inbuilt styling of Midjourney of that time was Midjourney version 4. Version 5 was rolling out later in the development. We figured out to try out all kind of styles, inbuilt styles Midjourney, and we got to conclusion that we better with using styles as prompt tokens. So just putting inside the prompt itself styles in style of something something, that was much higher rate of control than using the Midjourney style. That was more unpredictable. Another thing we were trying out was character sheets. We were going for a consistency, and then we figured out that cutting this up and creating image out of each of them is very, very time consuming, and we didn't progress with it with using spreadsheets in Midjourney, generated from Midjourney, but we later on implemented this approach in later stages, and you would see that's actually we did learn a lot from it. So next thing, so once we finished preliminary research, I've set out and said, okay, so we need to do libraries. And the idea behind libraries is we would create those token representations as we did with format. So you can see children's book illustration, editorial, as was in the previous panel. But here we have specific panel just for format and specific for subject and world and everything. And the idea was that we need to create a consistency, a visual consistency, visual language consistency for our data sets. And the way to do it is to have the same base. And here we're trying to put the same base to also using same formats, same subject libraries, same world libraries, same style libraries. And the idea at the time was that this would be used as tokens representation. And from those tokens, we would construct a prompt and then would use that prompt from Midjourney. And in this way, we can gather much higher level of consistency. So consistency was always the name of the game for us. How do we create the character that looks the same but doing different things? And how would we generate data sets out of it? One thing I would like to add is something we did there. Also, we had the Midjourney Research Station, which is not shown here, and we had the Style Research Station. So Research Station and Miro, we just put those blocks and we said, you know what, if you have some experiments, do them there. And if you gain some valuable knowledge, take it from there and put it into the production. And this is one of the iterations of it. We would go here and would research and seek for better styles, better tokens that would serve us better. And then those tokens, for example, here is the example of proposed tokens to go into the library to be used and questionable tokens to go out. So again, the approach was very iterative. It wasn't a one slap solution. It was about creating a system that would improve itself as time goes by. It was very important. So, and that's what we did as research. And with that knowledge, we set out to create the data sets themselves for the fine tuning. One thing I would like to add is that by that time, I've been working with a guy named Sam, who was a very talented designer. Really liked working with him. Then also Dennis joined us as Stable Diffusion trainer, I would guess, artist. I don't know how it's called. And we had also several people like engineers and advisors and people from all parts of the company working with us. So whenever I say we, I mean the whole team that was working in the project at that time. So that was what we were doing in March, in April and May. Then by the I'll just scroll to the place. Sorry, the point is that Miro boards, I just loaded all the 3 boards. I have chunked this into 3 boards in order for it not to be that heavy, because Miro with a lot of boards could get heavy. And by the way, I'll also address that issue later on, how we solved it. So we set out to create the first data set. We called it actually data cycle, mainly because there were two distinct stages in development of data set. There was the visual development with images, feedback, and everything. And the second thing was actually spooling them down to disk and creating a file, a zip file with images and captions that would be later on used in training. So for us, data cycle was the visual part, and data set was the actual file, the spooling and captioning and everything. And in general, in theory, one data cycle could create a lot of different data set because you can pick different images each time. You can caption them differently. You can augment them with additional images that one. You can combine data cycles into the same data set, what we eventually did. So this distinction between the visual part and the dataset part, the technical part, was very handy in the process. So we set out, this is the first panel of the data cycle. We set out, we put some tokens for styles, did some preliminary research, put our characters, and then started to create the, the table, the matrix. And the matrix here, again, we coming from previous experience of using things like styles, energies were kept, but instead of attire, we were starting to use attributes, and we were figuring out as we went, we figured out what actually works best. Once we did all kind of variations on the characters, we did meetings with the design lead, and he gave us pointers and what to throw, what to keep, what to improve. And that's also where Miro shined really well, because we were using these sticky notes with feedback. And even you don't need to actually write things down. This was very convenient because we were live. We were just putting those sticky notes, or even sending the board asking for review, and then asynchronously getting to board and seeing the review already on the board. So that again was really, really instrumental in our process. Once we got feedback from the design lead, we set out to actually create the dataset. So we took this image and then iterated on top of it. Here we see the tokens for the locations. Again, that's all coming from the libraries that we've seen before. So each time we would create this panel, we would go to a library, pick some tokens, copy them here, and then you already see. So it's a very, very visual. It's very convenient for visual people, for designers to work with. And I do understand the need for graphic oriented people. So we created Louisa, we created Neo and Moonbeam. By the way, a very important thing is our captioning strategy. This is a captioning strategy, how we would caption the image. And the idea here is, first of all, 00 Louisa. And one of the things that we were thinking is we need to create a token that would be a token for that character, but we need not to mix it with something. So we didn't want to mix it with girl. We call it when you take um, a widely available token like a girl that has a lot of representation in the latent space, and you put this specific image, generally this specific character would override the girl, and then each time you would request a girl, you would get Louisa. So we figured out we don't want to do token overloading. We would like actually keep our token separate. And I started to probing Stable Diffusion, seeing what tokens are not present. So what is free? And we did some tokens, and eventually we settled on that whatever token starting with numbers is generally doesn't have representation, so it was some random garbage. So we said, okay, that's good. We would start with 00 Louisa, and maybe if we create some other Louisa kind, we would take 01 or something like that. But again, numbering the token as prefix is worked for us really well. Same for Neo and Moonbeam. So 00 Neo, 00 Moonbeam, and so forth. One of the key learnings here is that dragons are hard to work with, mainly because dragons are underrepresented in latent space of Midjourney. So it was really, really hard to work with dragons in Midjourney. It was hard to generate them. It was hard to get consistency out of them, even with image to image. And it was very challenging. And same goal for Moonbeam, but Moonbeam had other problem because it's an animal that goes on four, right? It has hooves, and we had a lot of interactions with stuff in our stories. We had, and then he took this magic wand, or he had the camera and he takes some shots. So if he has hooves and he walks on all four, how does he interact with objects? Okay, we have this like my magic pony, right? And they did with the horn. They had like this magic thing. They could levitate, but good luck explaining that to stable diffusion. So we figured out, okay, yeah. So um, working with the horse-like creatures was also challenging from for other reasons. Additional thing that we were adding there is also secondary characters. We had secondary characters in the stories, and we figured out that we need to some sort of consistency. This is a trial of consistency. And one thing to say is that dataset 01 was actually the pilot. So it was a trial dataset to figure out how we do it. I don't have here training results. We had training results from this dataset. It wasn't, we didn't save that on the boards because it wasn't really representative, or it wasn't particularly good. But again, we saw improvement, and we said, okay, we're in a good direction. We're doing it right. We just need to keep doing it. Second thing, okay, so then we came up with data cycle 02. And data cycle 02, it was the next thing, was slightly different because first of all, we ditched the moonbeam and the dragon, mainly because we said it was very complicated to work with a lot of characters, and doing these huge tables for all of the characters would be really, really sophisticated and hard. So we would concentrate on one character, and we took Louisa because she was easiest to work with. Second thing, and actually interesting idea, it was the composite approach. So what we did, we used the data set. We took out some Louisa. We took out some Louisa concepts, and from a character sheet, we would generate Louisa and then generate character sheet for that Louisa, or the other way around. We would generate a single character, generate then character sheet, and then cut the character sheet into single images, and would use those as image to image. So the idea was having single character, cut it out, and create more characters. So we would have this library, and this library is a character library. This character library, so that's Louisa in different poses, doing different things, and she's without any background. She's all by herself. And then we would have these backgrounds. So that's actually not backgrounds, that's locales or settings, as we call them. And we would take city center, forest, desert, and we would create several iterations. I specifically asked, we were starting to create the first, we started with only one color, with only one variation, and very soon we figured out, okay, we don't have, that's actually repeating itself. So all our images would be the same color, it would be the same palette, but we need a diversity. So I asked specifically to create different colors for all of the settings. So as you see here, some of them are green, some of them are blue, and that's by intent, just to create a variability. And then randomly, we would take Louisa and would create a composite. So we would take one, that's actually, let's try other, I think. No, that's also, let's try here. Okay, yeah, that's a good idea. That's a good example. So that's Louisa, right? And we would put this, you see, so that's a composite. So we would cut out Louisa, sorry, in Miro. Miro has this magic remove background tool. We would use that a lot. And we would cut out the Louisa, and we would just plop her on the image. And then you would select this image. Sorry, something not okay. Yeah, Miro is a bit laggy. Then we would select the image. There is copy as image. I would show it here. We would take both of them, do copy as image. That's parallel to copy merge in Photoshop. We would copy as image and put it into Midjourney, and then run it through the image to image with the same prompt. And that's what we get out. And we started to see improvement in consistency. This composite approach was really, really the next stage in our development. And we started, so right now we already have Midjourney received several updates since then. We already have the ref style, right? So you can already have single specific characters sort of trained in Midjourney, but by at that time we didn't have that. We need to figure out by ourselves. So that's our attempt at gaining consistency for a character, and it worked. We started. Sometimes Louisa wouldn't be like herself, like spitting image off, but it was close enough. It was the same character, maybe sometimes drawn by different artists, but it was close enough. It was the same girl. So that was Louisa. Second thing we figured out, we need interactions with objects. We did the same approach. We did a composite. So we took out Louisa, give her the object, and put her on the image, copy as image, Midjourney, image to image, generate some other image, and that's also proved very, very effective. We also created an object palette, as we did with styles and as we did with everything else. Here we have the object palette. Same goes for secondary characters. Again, secondary characters work as well. Not every time it would work, but sometimes it would work really good. Sometimes it would less so, and it would take some iterations, but in general, it worked. And secondary character, so we had several goals for the secondary character. And by the way, this one is we asked to dump all the stories generated, did some analytical research, and that's why we have to first we did ourselves the most like cute and the most popular characters, and then we took out from our stories statistically what are actually recurring characters that we had, and those are the recurring characters from the stories themselves. So data-driven development. That was the second data cycle, and that was the first data cycle that actually oops, I think, yeah, and it moved some things. So, and that was the first data cycle that we actually went out in production really well. We started to fine tune. And here as well, we started, we figured out, okay, so that's already fine tuned. We figured out that we have a lot of files. We have, each time we fine tune, there's a huge file coming out, and sometimes even several files, because it would save intermediates. So if we're training for 8,000 steps, it would say every 2,000 steps and stuff like that. So we're starting to get a lot of files, a lot of visual information and technical, and we need to organize it everything. So we came up with this training card, and this training card is about, first of all, it saves all the data for the training, and it also has links to the drives and everything, so you can go and click right from the board. It would be super convenient. And second thing, we also would put images side by side, and we will always trying to figure out what is the best way to gauge the model, to check out, to test the model, how to see how well it performs to the task given. And the task given is to create illustrations. And it's also about the idea of if you're gauging a model, first we need to see the gradient. So we need to see the model, how it performs in the very raw basic one without any prompt fine tuning, because prompt tuning can get a lot of effect. So we put the raw output versus the optimized output. The optimized output would use some good tokens and negative prompt and everything we knew how to do. And that also was a good exploration for us how to actually optimize our outputs, and how in prompt engineering, how well we can construct with prompt engineering things. And that's the idea. So you can see there is actually a big difference. This, you see, this is burnt images. We call it overfitting. Burnt images, and that's very problematic. Each column is a checkpoint. So that's checkpoints and the generation. And then you see there's a lot of difference when you try to see the when you try to optimize the prompts. The quality can get better substantially, but again, this specific model wasn't really sure. And also something important to note, we were not only measuring how Louisa performs with different characters, we also measuring how, for example, the model can handle things that it wasn't trained on. So this illustration of mountains, um, for example, this is volcano, how well it would render volcano, right? How well it transforms the style. So we weren't only using to gauge the characters, but we also were really thinking about how we can impart the style on the model, how we can teach the model to create things in specific style, create a specific visual language. That's also was very important for us. So we see here some trainings. These are big charts for research projects. This actually this panel is about training speeds. So we gauge. Okay, we have a lot of training parameters. How we combine them. What parameters create best results for us. That was also a fun experiment. I think this one is the same. And this is actually Felix, the next character that's from the data cycle 03, but I also put it here because that's a model card. So that was in July 2023. Um, that's what we did. So we did data set and we did some training. Also, something that was really, really important, we concurrently in the same month, starting somewhere from actually May, we started to figure out that we need an exploration template. An exploration template, that's also a panel. But the idea is that we have a lot of questions. We don't know a lot of things, right? So we don't know the stable diffusion's totally new thing, very, very fresh. And we need to figure out things. We have some assumptions, but we didn't knew for fact what they were. We heard things in YouTube. We heard things that people say on Reddit, on different forums. But we actually need to figure out by ourselves, are they really valid? And if they are valid, how do we use them? And that's where exploration template comes into play, because that's development for us, not not only to store the visual information, but also to recall it. So one of the problems that we would do kind of these small tests, and then we would come to those tests a week later on, or even 2 weeks later, and you would look at them and say like, what was this about? Come again. And then I said, enough is enough, let's do it in proper way. And that's where we came up with the exploration template. And the idea here is, even when I'm coming here a year after, I still can understand what this test was about. So this is feasibility of different base models, right? So stable diffusion is trained on top some base model. There is always a base model that is some foundational model that something is trained on top of it. And that's where this card, where we started to check the base models. And we have premise, what we're checking, approach, how do we do it, and the conclusions. And that's really, again, I put the most important things, that was one of the most important things. This is head art exploration by Dennis. Can he draw funny faces in Miro? Apparently he can. That is part of our storytelling. Then we did some other base model checkout. We took some more interesting models from, you can see I even printed out CVTI. And CVTI, models from CVTI, it's not only about can we use those models, would they produce good result, but also about licensing. When you're doing stuff on a commercial level, you need to think about licensing and what like legal side of things. So it also was very important. It's not shown here on boards, but we also had the lists of what licenses do we have, where do we have them, how do we use them. That was on the base model. That's some training and sampler comparison. This is the generation. So here we played with different samplers. You can see like there is a lot of we tried out a lot of samplers just in order to understand. I love this one. We did some really nifty results, but eventually we sat down with 2 samplers, the DPMSD. By that time there was also conclusions. And by the way, Miro is also not only about sorry, it was not only about research, this specific panel, but prompt renderer. That for us was the deliverable. So when we talked in between ourselves and the team, we said, what do we need to give to the developers that developing the application? The application was full stack, and it was Google Cloud and cloud functions and machines that running, but we need hard code that was integrated as pull request. And I said, this is the format that we're going to deliver things. And then it was much clearer. So we need to deliver a file and we need to deliver settings. And once we had this this card, then this is actually the representative of the whole process that we did. So the data cycle, the data set, the all the research. It all boils down to this renderer card that we then passed it to the application. We actually got very decent, I think, very good actually results in the production itself. So once the application started rolling, we started to see outputs and we saw some really interesting things. I'll zoom out. So this is Louisa with objects. With this is 512 by 512, the native resolution, and you see the secondary character. So we actually it was doing the job. It wasn't perfect, but it was good. It was great progress for us. I was really excited about it. So data cycle 02 finished pretty much, and then we started data cycle 03. Data cycle 03 was about Felix, the character. We again came out with the same idea of creating first the character without any background. We took the backgrounds from Luisa and we continue creating composites with objects, and composites with secondary characters didn't go in production because we then started to do co-training. So when we would take Luisa and Felix and train them together, sorry, and that's why we didn't have any secondary characters. We figured out we will do it in other way. So we don't have here output from the co-training, I think. I'm not sure, but I would show that we were our exploration templates. We were starting looking at different base models. So that's 1.5. You see 1.5 versus deliberate, and I think yeah, it's co-training also. If we can co-train together, and we figure out that deliberate delivers much better result. It's being much better model, and this is about token overloading that I was previously explaining. We also figured out at some point, are we sure about token overloading? We had an assumption, but we need actually to check it. This is us checking the models. Is it better to call all girls, to call all Luisa girls, or we would separate 00 Luisa and a girl with different tokens? And eventually we got to conclusion that the model is much more elastic, much more pliable when we have different tokens for girls and different tokens for Luisa. Some exploration by that time. SDXL started rolling out, and we actually started to see some qualitative change. We started to see much better results with the same data sets, and we didn't even train the data sets. We just used LoRa's, and LoRa's these is like thin layers for the models, and it was much better because LoRa's take less time to train. They were much lighter, they were smaller in size, and you can stack up several rollers in one generation, and we were really excited about it. SDXL is also coming with a much higher resolution. It was really cool. Here the continuation of exploration of SDXL. So once SDXL started to roll out in August, I think, I said, okay, we need to start rolling the research project. How do we train? What do we do? How do we implement it? Because we cannot just throw it inside. We need to figure out how things work, right? Also here you see different in captioning. So we figure out which style of captions are better for a stable diffusion. Is it Buru or Blip? We didn't had very specific conclusion, but we figured out that Blip creates pretty much the same results, so we don't need to change anything, and we continued using Blip for captioning. Here we have what I mentioned, the deliberate. We tried different expressions. Can it create different expressions and different compositions? And see, you can see here there's some images that are actually much better, right? So that's having a deliberate as a base, and yeah. So we had two data sets, Luisa and Felix. We were working. By that time also, in the same time, we started to figure out how can we control the composition better. That's where we started to figuring out. We already worked with control nets, but we didn't implement them as part of the pipeline. And one of the ideas was to implement control nets in order to control the composition. and this is our checking out which control nets can control the composition better, how we can utilize them. Same goes for here. Also image to image exploration. So combinations of control nets, combinations of masks, be it depth mask or Kenny or some other type of control net, maybe image to image together. So we're figuring out things out with the idea that we would later integrate it into a pipeline at some point. Also, we did a prompt engineering panel. We had a prompt engineering panel, and the idea here is that we said, okay, we developed the data set, we developed the models, we developed the training, but we also prompting is super huge part of it. You can gain much better result with only prompting, with only prompt tuning. And we said that we need to actually understand better all the assumptions that we have about negative prompts, positive prefixes, suffixes, formats, and what kind of negatives would you choose embeddings, would you not, how much keywords is best, be it a few keywords, maybe a lot of keywords. So this was our place to check these assumptions out. Some metadata, meta management. So meta management is not about the data sets and the work itself. It's about the whole process, managing the process. Three things. As I mentioned, there was a lot of things going on. There were a lot of files, there were a lot of models, there were a lot of data sets. So one of the things I put down to a board, so this was in the middle of the board, naming conventions, how we would name the data sets, how we would name the files, the models, because visual people, they have a funny saying in the world that all the graphic oriented people, they have this final, right? They have like movie final two, in my mama final, this time I swear final two. So this was the idea, to prevent that final thing. And also the second thing was Miro is very versatile, it's very powerful, but the problem is that it was very powerful and it was very versatile, but the thing is, when everybody's putting everywhere everything, it gets cluttered very fast. And I said, okay guys, we have this process here, it goes from left to right, and this minimap specifically, it's supposed to outline what things on the board would go where. And at the end, our board looked pretty much the same. So we had the current data set development in the right side. On top of it, it was all the trainings that came out of the data set. And then below, we would put the data cycles into archive and reference. So when we create a new data cycle, we can just copy paste into the new data cycle. And then at the bottom, we had the abyss of things. So the abyss of things, these were that's practically the archiving bin, the elephant graveyard, as I call it, and that's where we put things that were later been taken out into the archive board. So we tried to have one board that was constantly in the work, and once we finished with everything and we didn't need it anymore, in order to make the board lighter and easier to work with, we would move it to the archive board. Another thing that I've set up is the DSL dictionary. One of the things that we were getting a lot from other team members is that we sound cryptic, and because we always talk about these models and fitting and overfitting and bleeding, and there was, what are you talking about? Because they weren't in everyday environment of those trainings. So I set up this DSL, and I said, you know what, fair enough. Not only to the other team members, but also for us, because when we're measuring something, when we were measuring the model for something, we actually need to have clear understanding of what we're measuring of. What does it mean? So when we're measuring bleeding, when the characters mix, right? So we need to understand what is bleeding or fitting or underfitting. That was really important for us, and that's why I created this dictionary. Another thing is the dataset cards. So as you figured out, I'm really keen for cards. And dataset card was the idea of creating this data cycle. We wanted sometimes what to keep the data cycle, but we didn't all the in betweens. We didn't need all the composites and all the preliminary token development and all of those things. So we came up with this idea of dataset guide. This is, you can think about it like a zip file for the data cycle. So we would take all the characters, all the crucial ingredients, we put this into this data set card. And if you need to develop some more images for that, you can always take the background from the top, the um, the secondary character from here, then create a composite and create some more additional ones. But in general, that was the idea, to save up on space, on the amount of items being in the board at every given moment, in order to make the board be lighter and easier to work with. Okay. So that was about August, and then again, let's scroll to the beginning, some spoilers. And then I said, okay, so we pretty much got the image side figured out. We do understand how it can be done. I've given enough instructions to the other team members so they can proceed by themselves. And I said, but the problem is that no matter how beautiful the story is, if the story is shallow and not that interesting, people won't buy it. And we need to address that. And I said, okay, so we need to address that. And I just switched to storytelling because, again, as I mentioned, I really keen about storytelling and I really like this. So for me, it was very natural thing to do. And I just took responsibility. So I just volunteered to spearhead the effort. And I came up to the code, and that's what I found. I found this prompt. This is how I found it in the code. And I said, okay, cool. I do not understand anything. And if we have pull requests inside the code and we have code changes, I cannot compare it to anything. So we need to first figure out what we're dealing with. And then I used long S to prompt YAML conversion prompt. I created a specific prompt in order to create a YAML out of it. A few words about YAML. YAML is yet another markup language. It is used extensively in DevOps, in infrastructure. But the idea again is YAML is a text format for structured data, and it's about readability, editability, and human friendliness. And I think it's one of the best formats there is in order to write things down, specifically structured data with lists and points and objects and fields and everything. Much better than JSON by far. And that's where I said, you know what, I'm doing everything in YAML. I have my own prompt library, and I write my chores in YAML. I would write love letters in YAML for my wife if she would understand it. But we are going to manage everything in YAML, and that's why we transitioned to YAML. And since then, we manage everything in YAMLs. So again, as with Imagen, with image generation effort, same here. We set up a board, we set up an effort. We said we need first to research what makes good story tick, how we create good stories. I know intuitively how to create a story, but that's an art of itself. That's also a science, and that there are things. So we started to research more concretely about the monomyth, about the Campbell's hero's journey, acts, beats, all kind of things. Then we actually had a good idea of taking inspiration from a cartoon series. The point is that cartoons for kids, they're very episodic and they're very formulaic. So sometimes they would follow the same formula. And we started out with analyzing this formula, and that's what we did. We draw the best shows that we knew from our time in the 2000s from Cartoon Network, and we started to analyze how heroes look like, how antagonists, what are side characters, and we s- we started to put this actually into YAML. As I mentioned, very keen into YAMLs, and that's UC. So that's a show that is deconstructed into YAML, and that's actually a nifty good process, because how would I come up to that? I would go into ChatGPT and said, okay, what do you know about this show? And he would write something out. So that's priming for ChatGPT. And then I would say, you know what? See that. And then I would paste some text maybe from Wikipedia, or maybe from fandom page or something like that, would augment the data. And once it had all the context for it, I would say, okay, and now output everything you know in YAML. And I would get some YAML, and sometimes I would even give him the YAML that I would like. I would say to him, this is the YAML that I would like. These are the fields, augment it as you would need and see fit. And then he would make of it. And this approach made the ability of digesting a lot of information really, really fast possible. So you can come up and take very, very complex data, very complex concepts, and digest them very fast. We continued developing it, and then we came up eventually with ChatGPT. We're always working with ChatGPT in all fields. Eventually, we came up to this procedure where we said, okay, so one of the things that we need to make better stories is better world, because the world, when you can always say to ChatGPT, generate me some story, but the story is flat and it's pretty monotonic, and it's not that really interesting. So how do we make ChatGPT create better stories? And that's our approach. Was first, let's create the world. Let's lay foundation. As with everything, if you lay foundation for it, you would have much better structure. And that's what we did. That's and also we were about depth development, so historical events, lore, things like character relationship, maybe backstories, maybe history. That's what creates depth in characters. One of the things also we did as one of the efforts is we tried to take already existing popular stories, specifically Gruffalo, because I like Gruffalo very much. That's a really awesome book that I've read with my kids a lot of times. And we tried to put it into structure. So we put it into YAML. We use that YAML in generations. We tried to generate some stories with the Gruffalo structure. And we really fast we understood that if we're generating with the same structure, the output is pretty much the same, and it feels like Gruffalo. So it feels like Gruffalo, but it's not Gruffalo, it's Buffalo or Muffalo or whatever. And we were trying to create better variability, but we ditched this idea because we said there is better way to do it. Was we needed a lot of work in order to make it work, so we decided to do something else. Eventually, what we ended up with, so this is in between. I think this is one of our earliest prompts. So we were compiling. We had the YAML template. That's a render of this YAML template, right? So this is very, very long YAML, and we would have a YAML template that would say, okay, here is the world. Here, that's the directive. Here is the world data. Here are the characters, the side characters, additional data. And we would hold all this information in YAML, and then people like product managers or maybe an author can go in, edit those YAMLs. So that's basically a text file. He can edit those YAMLs, and then we would pull those YAMLs into code. And one of the best things in YAML is also it's parsable. So we can just edit those YAMLs inside the code, commit pull request, and then it's already in the code. We don't need any further integration. So we eliminated one stage of integration. So it's already integrated. YAML's by default integrated in Python. That was about the storytelling. So that was a storytelling effort. One thing we had really hard time is with assessing stories. So we had internal tool with stories being generated and then images, and we needed to rate the stories. We needed to understand how well are the stories, how good are the stories that we were generating. And we had this internal tool, and the rating process was tedious. It was a lot of stories, it was manual, it was complicated. And we tried to figure out how we can alleviate this problem, how we can unbottleneck the bottleneck. And that's where we came up with the we called it auto editor. So the idea for the editor is somebody who writes those stories and decides is it good or not good and maybe rewrites them. We created a series of prompts. We first figured out how editing work is performed, and then we created a dimensions upon which we can measure stories. We gave the prompt the lines. So for example, we would say humor, right? And how do you measure for humor? And then we would say, okay, low humor is when everything is expected and there is a little of to no wordplays and so forth and so forth. I think I have, yeah, humor. Yeah, you see. So we had examples of high and low, right? High, medium, and low, just in order to explain. So it's not enough just say, okay, rate me to humor. If you want much better results, you need to define what humor is. And you know what? Defining humor is like challenging. Yep. Um, so that's about humor. We had several more dimensions. Relatability, I think, and several more. I don't remember them right now. But we generated those, and then we did the priming. We said you are now a child's a renowned child author, and you know how to write stories. You also inside child psychology. We did a single agent rating. We did get good results. And then we did multi-agent rating, and we defined several personas, each of them of different kind. And then we said to them, you know what, um, these are the dimensions. Each of you should rate them. And then we averaged the rating of 3 personas, and that's actually was getting us much better results. Um, um, yeah, okay. So you see here that's plot complexity, language difficulty, moral message, humor, emotional depth, age appropriateness, character development. So that's 10. I think you were rating for 5, the first 5 one or something like that. So we took several of them, only 5 of them, and rated on them. And that's the idea of the flow. So where we would put this, and the idea was to put it into classifier, right? So candidate generation classifier. And we were getting great results, but we didn't had the chance to integrate it into our rating. We did run tests. We saw good results out of it. It was supposed to be integrated on our internal tool, but by that time things changed. And specifically, one thing I would do short run, that's rabbit theory. Rabbit theory is the idea of dataset generation, automatization, how we would generate automatically datasets. So we already were well versed with datasets creation, and we were looking into can we generate those datasets automatically and maybe train characters with fraction of cost. And this is the same composites, but instead of running it through Midjourney, we were running them through SDXL with LoRa, and we were getting really good results. So it was very promising. Um, Same goes, yeah. So that's the output of the rabbit theory. That's the output, and we were getting good results. We had good base models. We have good secondary characters, and then DALI hit the market. It's not even hit the market. We were starting to hear about DALI, and then we gained some access through Microsoft something, and we were starting to see a qualitative difference. So DALI was much better. We were really shocked, and we said, "Oh my God!" So each time we were at the point that we already think we got it. We already got it figured out. Then something new was landing, and the qualitative jump was so huge. It left us in shock. And this is you can see there is a difference between SDXL, LoRa, SDXL with LoRa, and DALI. And I think DALI was much better. It maybe sometimes it wouldn't be better quality wise. But again, I'm reminding you that's September, October 2023. It's the first time DALI 3 came out. Was only fresh. Uh, so DALI was much better, not in maybe quality, but more in the contextual understanding of the scene. So it was creating much better compositions. It was much better with character differentiation, and it was API calls. So we didn't need to implement kind of sophisticated pipelines with machines and everything. It was just one API call away, and it was much simpler to work with. So, and we saw the DALI coming out and said, okay, we need to figure out what's happening here because it's going to get out and we need to utilize it. If we can utilize it, if it's cheaper, better, and faster, we definitely need to understand how to work with it. So that was DALI. And as I said, some things were starting to change, and that's October 2023, and things did change. The project was clearly heading for a conclusion, for sunsetting, as it was said. And I've gathered up the team and I said, you know what, guys, we have two options. We can sit here, feet on table, and do nothing and whimper out, let the project whimper out, or we can do something really cool. Let's like the last dash to the finish line and create something really exciting. And they believed me. and and that's where we figured out that we would do something really cool, and we called it the final story. So the final story is the idea that the same like the final fantasy series. It's the final project, and I said we'll call it the final story appropriately. And we ditched everything we did on the upside, and we said we would create a better app, faster app, and we would iterate much faster. We didn't have a lot of time. We had a month at best, and we would do it everything in collabs. So we would do it in code. We would use Colab as a presentation tool, and we would create an interactive stories. So that was the idea, and we actually brought the project back to its original idea, the inception idea of creating interactive stories. We said, you know what, we started with that, we might just finish with that. That's where we started the final story. The final story was the code name for this project, for that effort. And we started with laying out groundwork for the world. We set out with creating this like book kind of map, like you had back in the day. You had in the book, in all the fantasy novels that I was reading when I was a kid. You would have a map with places. That's what we did. In order to visual the places that would how they would look like, to envision them, how they might feel like. Felix is then for center. We centered on Felix as a main character. We liked him a lot, and we set out on Felix. We had a lot of experience with storytelling by then. We working, as you see again, working with YAMLs. That was actually the conversion points of visual and narrative, where we started to figure out how to work, how to create narrative. This one is, we said that we're not going to use our existing infrastructure with stable diffusion. We are going to full dash to DALI 3. We're going to fully use DALI 3 with API calls, and we figure out that we can use DALI 3 to create, in order to create consistent character with text only, and this is what you see. So you can see character is really, really consistent, even though it's not image to image and it's not fine-tuned. That's DALI, and we got such good results. We were really, really excited about this. And you see the Rupert, the secondary character. We also figured out we might have additional characters. We were throwing a lot of interesting things into the mix. And then we chunked. So that's first tryout. So the development of interactive, it's always started like this. We started out in the ChatGPT window. We said we were laying groundwork with the YAMLs. We would inject the YAMLs directly into the window. We would say, okay, so that's the YAML for the world, that's YAML for characters, that's YAML for the narrative, that's YAML for the story. And now start to illustrate those. And by then DALI 3 was already illustrating, and or maybe it create a prompt for image for illustration. And that's what we did. And we first started to create, so it would create an opening, a stage, and then would give an option how to progress further. And we created 5 options: safe, daring, fantastical, desperate, and absurd. We tried out several different kinds of options. They all got really interesting results, but this one was pretty much the standard. We eventually, I think, got down to 4 options, but we ditched the absurd, but it was the idea. And then once we get this result, we did another prompt that would say, okay, that's the story, that's what the player chose, generate more. And then it generates the next chunk. We started with rolling first, but then we did the rolling. We just did some other aspect. I would come to it shortly, and we would illustrate it, right? And we got really cool results. We were so excited. Eventually, but one problem here was that by the way, yeah, this specific, that's really funny because by that time API was only for DALI 2. We didn't have it. So in order to create the images for DALI with DALI 3, we need to go to the web version. So what we did, we generated DALI 2 and then went and generated also for DALI 3. That's what you see here. And then this is a copy from already the collab that we were working with. And I really like the DALI 2 images, I have to admit, because they had this kind of creepy, creepy, funky feel to them. But the images that we were generating were amazing. So what I was, that's a mysterious visitor. So one of the problems is we were getting is that if you're getting ChatGPT generate story in episodic way, in step by step, stage by stage, step by step, it's going to go forever unless you say, okay, now conclude. Then it's going to conclude the story. But we needed to figure out how to end things because we cannot go forever. Because if you're going forever, it's not really fun. We need some conclusion. And the conclusions we were getting, they were very unsatisfactory. And we need to figure out a way how do we address them? How do we make this story more complete experience? And a mysterious visitor, that's the idea behind it, was that we would write the story ahead of time, but we're not going to write it fully. We're going to write it in points, and then we would present ChatGPT, present the system with this outline of a story, and we would say, you know what, this is the outline, and the outline was also chunked into stages. So each outline had like 8 stages, 6 stages, 7 stages, and this is an outline, and there is checkpoint 1 where the story starts. For example, here Felix the Fox starts at its home, and then he gets out and he starts at the crossroads. And then the next stage, when he progresses, there is a strange visitor coming in, right? But we were giving the users the option of control, but it was a feeling of control, but it wasn't actual control. The control was about how the progress is made from stage to stage. So Felix is going to end up meeting this stranger no matter what. But how he's going to do it, that is up to the player. And that's what ChatGPT was generating. So ChatGPT was generating not only the description, the opening, the description for the stage, the options, then the transition from the options to the next stage, and then the options for the third stage and so forth. And that's actually how we got really good results. So it's, on one hand, it does feel kind of random. You still pick how the story progresses, but you get enough of variability. But on the other hand, the story does conclude in a very satisfactory way, and we got those stories pre-built, and we figured out that's actually really good. That's actually a really good point where a children's author or somebody who actually writes stories for a living can come in and write those outlines and read those stories and see. That's actually a really good ground for people who are into storytelling to work with the system. That's where they could shine. That's their new kind of tools that storytellers could use. That was the idea behind it. Yeah, so we had this. Unfortunately, I don't have the call up, it's not working. For various reasons, but the collab pretty much looked the same. And by the way, we did not only images, we also had narrative. It was creating with 11 Labs, it was creating voiceover. So most likely you all by now have heard 11 Labs narrated videos out there. So imagine the same one being narrated by 11 Labs voice. And once the narration was done, we just stitched all of those images into a slideshow with the narration, and it was a kind of like a slideshow, narrated slideshow. And that's how we presented it. And that's how we presented it at the company offsite. It was exciting. We got really good reviews. Then we spent most of the November shutting down things, putting everything into writing, memorizing all the knowledge, arranging archives, and the story was closed. And that was really fun ride. I was very excited, super passionate about it. And yeah, I'll stop presenting. And I'm very grateful for the opportunity to work with all those people. And yeah, it was fun. So right now right now I'm working in the AI field. I'm using ComfyUI in order to generate some nifty workflows. I'm helping companies create automations in their companies with AI. I have my own project about storytelling. It's more again of a passion project, not really commercial, more of a passion project about a book I'm reading, and I would like to create also kind of this interactive storytelling for this book. And that's it. And if you have any questions or you find this useful, hit me up, comment, share, please do. Would help me a lot. Bring this knowledge to as many people as possible, and hope it works. Thank you very much and have a great day. Thank you.